Checking a solution. Jonas Salk developed the first polio vaccine. His goal was to eliminate the disease through creating a defense system vaccine in the person's body. 2 million children were vaccinated and no one contracted polio. Was he successful? So let's go over a few things before we answer this question. A solution is made up of two equal expressions. A solution is the value of the variable that makes the equation true. So let's go back to our problem to solve for it. So we have the number of people being vaccinated. So we're going to just put that number in right there. So we have 2 million. And then we're going to go times the number of those people who contracted polio, which was no one. So with that, 0. So 2 million times 0 is, we want to know if it's equal to 0, which in fact, any number times 0 is 0. So in fact, this checks out, and we can say that he was successful. So let's look at another example. Is x equals 4 the solution to this expression? Is x equal to 4 the solution to this? Negative 3x plus 6 equals 1. So for this, we would write minus 3, and then we're going to put in that 4 when we see the x. So we can put 4 there, plus 6 is equal to 1. So now negative 3 times 4 is equal to negative 12, plus 6 is equal to 1. Now, when we do this, negative 12 plus 6, we know we get the answer to be negative 6, which is equal to 1, which we would actually say this is not equal, because negative 6 does not equal 1. So we would say this is not a solution. So let's look at another example. Example 3. In 1938, there was an estimated 1,600,000 children living in New York, and 9,000 of these children contracted the polio virus. According to a popular newspaper, this resulted in an infection rate of 0.56. Is this newspaper reporting the correct number? So we have our equation below, and so let's fill in all the numbers in. So we have number of infections. So we can see that 9,000 children contracted the polio virus. So we'd go ahead and write 9,000 here, divided by the population at risk. So we can see that there is 1,600,000 children. So let's go ahead and write that number. Then we're going to multiply that by 100, and we're going to check to see if this is in fact equal to 0.56, because the rate of infection is reported to be 0.56. So the next step will be to take 9,000 and divide it by 1,600,000. So another way to look at this is 9,000 could be written as 900 times 10, because it's a factor of 10. So we could do this for the top and bottom, or we could just know that each 0 is a factor of 10, and so we can just go ahead and cross out 1 0 on the top and the bottom for each one. Let's do another one, and then let's do another one. So now we have 9 over 1,600. So this is a little bit easier to deal with when we start dividing. So let's now divide. So we have 9, and we have 1,600 on the outside. So we're going to go ahead and just add a couple of zeros because we know that we're going to need them. So 1,600 can't go into 9, so we'll just go ahead and put a 0 on top. We'll put the decimal straight up top too as well. Now 1,600 can't go into 90, as 90 is still too small. So we'll do another 0. Now we look at 900. 1600 can't go into 900, so we'll go ahead and put another 0. Now 9,000 is a different story. We add the next 0. So we can go like this. We go 1600, and let's just guess that it can go into 6 times. So 0 times 6 is 0. 0 times 6 is 0. 6 times 6 is 36. So we'll keep the 6 below, carry the 3. 1 times 6 is 6, plus 3, which is 9. So we have 9,600. So this number is too large, because 9,000 is smaller than 9,600. So what we can do is either go 1,600 times 5, or we could just go ahead and subtract 1,600, as it's the same thing, to get to what this would be 1,600 times 5. So 0 minus 0 is 0. 0 minus 0 is 0. 6 minus 6 is also 0. And 9 minus 1 is 8. So now we have 8. So 1,600 can go into 9,000 5 times. And then we'll put the 8,000 here. And then we'll subtract. So we get zeros. 9 minus 8 is 1. And we know we did this right because 1,000 is smaller than 1,600. So 1,600 cannot go into it, the 9,000 any more times. The next step would be to bring down that 0. Now 1,600 goes into 10,000. And we're going to look at this. This is pretty close to 10,000. So we would put the 6 right here. And then we'd put 9,600 right here. And then we go ahead and subtract. So we have zeros. Now 0 minus 6 can't be done, so we'll need to borrow. So the 1 becomes a 0. And we carry that 1 to make it a 10. But we still need to borrow. So then we can go 9 above and then 10 here. So 10 minus 6 is equal to 4. 9 minus 9 is 0. So we're left with 400. So let's go ahead and add another 0 below. So now 1,600 can go into 4,000 how many times? So we're going to guess that it's just 2. So 0, 0, 6 times 2 is 12, carry the 1. 1 times 2 is 2, plus 1, 3. So 3, 2, 0, 0. And now we'll subtract. So we have zeros. We'll need to borrow, as 0 minus 2 can't be done. So now we have 10. 10 minus 2 is 8. 3 minus 3 is 0. So then we're left with 800. But we also need to write down this 2 up here. But as we only need to check a couple numbers, we're just going to leave it there. So you can see in this next step, we'll go like this. So we'll go 0.00562 times 100, and we want to know if it's equal to 0.56. So then we'll go ahead and multiply. And remember, anytime we multiply any number, it equals zeros. So we're just going to add zeros there to represent that. The next thing is, when we move to the second 0, we add a placeholder for the 0, and then we also get more zeros. Then we put 2 placeholders for the 1, and then we're going to go 1 times 2 is 2, 1 times 6 is 6, 1 times 5 is 5, and we have zeros. And then we're going to add them all up. So we have zeros there. 0 plus 0 plus 2 is 2. And then we have 6 and 5, 0, 0. The next thing will be to place the decimal in the right spot. As you can see, we have 5 here. And we have 0 here, so our total is 5 decimals. So we start here and we move it over 5 times. 1, 2, 3, 4, 5. So we would write 0.562 is equal to 0.56. And we would say this checks out, because we could just round to the nearest hundredths and we'd get 0.56. So we would say that this is indeed true.